Hi guys, welcome to today's lesson. So today we are going to focus on triangles and quadrilateral riders, right? So riders are just questions that we are going to do that need you to apply some properties of triangles and some properties of quadrilaterals based on what you have at the time. So let's just jump right into it. So remember, when you talk about riders, there's a few things that you need to make sure that you go through properly. So firstly, you need to make sure that you read through the facts part. This will be the statement that I give you. So in the diagram below, ABC is a triangle with, and then because of those widths that I would have added, you will then need to mark them on the sketch to make sure that you are able to see them visually. And then you also mark your implicit facts. This will be things that are not really told, but you can apply them based on what is told to you. Then you read through the asked part. So this is where you then go to understand what the question wants of you. You devise a plan of action. This plan of action is very important because I promise you, most of you guys just go straight to trying to say, oh, let me try solve the problem. But if you don't have a plan of where you are going to start, you're going to include a lot of unnecessary things, especially in geometry. And then evaluate, plan, and restart, right? So that's what you then need to be able to do. Evaluating plan means you do execute it and check whether your solution does make sense. If not, you can always go back. There's now ways to check if your answer is even correct or not. Now, when you talk about tools for solving triangles, riders, so this is, you need to make sure that you know the properties of triangles. When I talk about properties, you know, we have like a scalene triangle, what are the properties? An isosceles triangle, what are the properties? An equilateral triangle, what are the properties? Even a right-angled triangle, what are the properties? So that's what I mean when I talk about the properties. And outside this, are there any theorems that we need to know that have to do with triangles? Also, you need to understand how to show that the triangles are identical. Remember, identical will be congruency. So this will be congruency. And then similar will be similarity, right? Because triangles can be similar or they can be identical. There's a difference. The identical means angles are equal, sides are equal. Similar would mean angles are equal, but sides are in proportion. Now, the types of triangles, as I said, we have a scalene, an isosceles, and an equilateral triangle. And you know the different properties that we have here. This, no sides are equal. No sides are equal, and also no angles are equal, right? With an isosceles triangle, we know that two sides are equal. Two sides equal, and two angles equal. Then with an equilateral will be three sides equal, and also three angles equal, right? So those are the properties of these types of triangles. Now we're going to look at what exactly how can we classify this according to the lengths of sides, right? So if I talk about sides, it means that side and that side are equal, that side and that side and that side are equal. So three of them makes this to be the equilateral, and makes this one to be the isosceles, makes this one to be a scalene, because none of the sides are equal. If we look at this from the size of their angles, then we can always say that this angle is equal to that angle there, which would therefore mean that this is a right-angled triangle, right? This will be an acute-angled triangle, and this will also be an acute-angled triangle, which is more of your scalene. And that one, we can always try classify it based on those lengths that we have there. Now, the terminology that you need to make sure you understand under the concept of riders is what is a theorem, right? So this will be a statement that has some proof to it, right? So if I say line AB is equals to line BC because they are being bisected by a certain line, that will be a theorem, right? And then if I want to talk about the converse of a theorem, I would say if a line bisects a longer line at point B, it will cut the line such that AB is equals to BC. So now we're starting with the bisection. But let's actually look at this from a more realistic way, right? So the theorems that we have, which I'm going to look at, also the converses of them, is the sum of interior angles of a triangle is equal to 180 degrees. Now, the short way of writing this, which you need to be able to know, will be to sum of angles in triangle, right? That's all you need to do. As soon as you have sum of angles in a triangle, a person would know that they need to equal to 180 degrees. So that's how you then write that down. Also, we have what we call the exterior angle is equal to the sum of the opposite interior angles. Now, this has to do only with a triangle. And how to actually see this will be when we have one side that is produced, which we're going to talk about as well. Then this will be equals to, if that was x and y, it will be x plus y. And the short way of writing this as well will be exterior angle of a triangle. And you leave it there. You don't need to then continue and say is equal to the sum of the interior opposite angles. Another theorem that we have of a triangle is to say in a triangle where two sides are equal, the base angles are equal. Now with this one, I want you guys to then think about how can I make a converse of this particular theorem? So I know that if my triangle has two equal sides, it's an isosceles triangle, then the base angles are also going to be equal. It means if I wanted to look at it from a converse perspective, I will then say if the base angles are equal, then the sides are going to be equal, which will then make it an isosceles triangle again. So that's how the concept of a converse comes in. Two sides are equal, the conclusion, two angles are equal, right? And then the converse will be if the two angles are equal, the conclusion will be the sides opposite. Those angles will also be equal. And then it still is an isosceles triangle. So let's look at it from the writing itself, how you're going to write the converse. Right, so the converse will be in a triangle where the base angles are equal, the sides opposite the base angles will be equal. So what do I mean with this? If I have something of this nature, this angle and that angle are equal to each other, it would therefore mean that the side opposite, which is this side here, and the side opposite, which will be this side there, will be equal to each other because they are opposite those angles. So that's how you look at this particular concept. Another theorem that we can try and talk about will be for an equilateral triangle, which says in a triangle where three sides are equal, the three interior angles are also equal to each other. Now, I'm sure you are already thinking of the converse, right? That if the three interior angles are equal, then the triangle will have all the three sides also equal. Right, so that's what we are going to say. In a triangle where three angles are equal, the three sides will also be equal. Now, in a right-angled triangle, here we are talking about the theorem of Pythagoras, right, which you are very familiar with. The square of the hypotenuse side is equal to the sum of the squares of the other two sides, right? And you're going to classify this in terms of lengths and see what it says. The converse of this will be if in a triangle, I have the square of the hypotenuse being equal to the sum of the squares of the other two sides, then the angle that is opposite the hypotenuse side will be 90 degrees. As you all know that the hypotenuse side is always the one that is opposite the 90 degrees, right? And the short way of writing hypotenuse is normally HYP, right? So if I say this squared is the same as this side squared plus this side squared, then I will know that this is a 90-degree angle. Let me repeat. If I say this squared is the same as this one here squared plus that one squared, then the angle that is here will be a 90-degree angle, because this will be adhering to the theorem of Pythagoras, which is the converse we are talking about. Now, with congruent triangles, remember I spoke about we can use the properties to talk about whether they are identical or not, right? If they are identical, it means the three equal sides need to be seen, and also the three equal angles need to be seen. But you don't need to prove both equal sides and equal angles. You can choose to show three things equal, not all six. So you don't need to show all of them to be equal to each other. What do I mean? If I prove by congruency, I will have a right angle in both the triangles. I will have a hypotenuse. I will also have a side. We call this RHS, right? I can prove this as one of the ways to talk about congruence. We also have what we call a side and an included angle and a side, right? And I can also use this to prove congruence. Not that I must prove it with the first one. No, I can use either one of the first two. Then the third one will be side, side, side. Remember, all three sides are equal. Then I can try and use this one as the third option. Not that I'm using all of them. And then the last one will be side, angle, side, which you can use either one of the four conditions of congruence. And then remember as well, we also have the similarity. And the similarity that we need to prove, we normally prove it using equiangular, right? Angle, 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 meaning you must prove all three angles are equal, but you just need to prove the first two, and then the third one will be equal as a result of the first two. So that's what you guys need to please make sure that you understand about the properties of triangles, right? And all of this is what you guys already know. But now, when we come back from the ad break, I want us to then apply all of this that we've spoken about in terms of the riders to then solve these questions and see how do we visually see the properties and how can you apply them in order to solve the questions that are presented to us. Please stay tuned. I'll be back just now.